Hello and welcome to the third part of our third lesson in our fifth unit, Sine Functions, in our grade 11 University College math class. So we've done one sketch so far using the 5-point method, and we are going to now embark on a second example. So without further ado, let's get to it. So we are going to sketch one cycle of the sine function y equals negative 0.25 sine x. Let's start by getting down those important pieces of information before we start our sketch. So the period is going to be, I've said this a number of times now, the period is 360 degrees. Because we don't do any horizontal compressions or expansions in the 11 UC course, our period is going to be most of the time 360 degrees, assuming we're talking about angles of rotation. So let's get to maximum and minimum value. Now, we notice our A value is negative 0.25, and we know that the high and low points correspond to our A value. So our A value is 0.25. So our highest point is going to be 0.25. Our lowest point is going to be negative 0.25. And our equilibrium axis, again, is going to be halfway between those. So x equals 0. Halfway between. The amplitude will be 0.25. That corresponds, as I said, always to our equilibrium, or our A value here in our function. And last but not least, the domain. So the domain, hopefully by now, you recognize the domain of a sine function is wide open, which is the set of all x such that x is an element of real numbers, no limits. The range is impacted by the maximum and minimum values. So our max value is 0.25, our min value is negative 0.25. Let's go for the range. So the set of all y such that y is an element of real numbers. We pop in our low point, our y value, our high point, and we know that y will be less than or equal to the high point, and that the low point will be less than or equal to y. So that is our domain and range. Let's start our sketch. So again, we're looking at the period, and the period is 360 degrees. So I have this whole space to use. So I'll start with 0 degrees here again, and take my 360 all the way to the far side. There's no need to squish it in here if you don't have to. Use the biggest amount of space that you've got. So the thing I do next is I want to divide this up into the appropriate number of segments, starting with 180 degrees in the middle, and followed by 90 degrees halfway between 0 and 180, and followed again by 270 about halfway between 180 and 360. So we have our segments sort of prepared here for us. Let's get our equilibrium axis on there. So our equilibrium axis is, that should be y equals 0. Yikes! Let's not tell anyone I did that. So y equals 0. Let's get that on the graph. So again, we're going to dot that. It happens to be right on top of our x-axis, no problem. Dotting it all the way along to the far side, and I'm going to label it y equals 0. Okay, looking good. So now we need to put on the first 3 of our 5 points, and those, actually we have to do the vertical scale first. Sorry about that. So what is the highest point we reach? 0.25. The lowest point, negative 0.25. Those are the only 2 points that are on there, so there's no need for us to try to squish this thing in, and because it's 0.25, just make it really small. There's no need to do that. We can put that anywhere we want up here. So there's 0.25, and roughly equidistant, there's negative 0.25. So we know where our high and low points are going to go. Now let's put those 3 first points on there. They occur at the beginning, the middle, and the end. And again, I want to say it as I said it last time, I'm not putting these on the x-axis, I'm putting this on the equilibrium axis that happens to be on the x-axis at the moment. Now, we're going to be putting on our max and min points here, but I want to point out that our A value is negative, which means that we have a vertical reflection across the equilibrium axis. So normally, our high point would go up here, our low point would go down here, and we'd sketch through and everything would be great. But we're going to reflect that. So the high points are going to go low, the low points are going to go high. They still happen, they just happen in a different order. So we are going to put our low point first. So 90 degrees has our negative 0.25, and 270 has our highest point at 0.25. So there we go. We've got our 5 points on there now. Now we sketch it together. So again, I'm going to try to make these curvy, giving myself a little bit of a tail there. Oh, that's pretty pointy. Oh man, it's happening. I'm doing it. Yeah, there was a terrible wiggle at the end, but other than that, I really did nail that one. Okay, so let's get our arrows in on the ends. There we go. And our graph is looking wonderful. Now we need to label our points. So our points are going to be 0 degrees at a height of 0, 90 degrees at a height of negative 0.25, 180 degrees at a height of 0, 270 degrees at a height of 0.25, and last but not least, 360 degrees at a height of 0. Only thing that remains is for us to label the actual equation, and the equation was, I believe, y equals negative 0.25 sine x. And there you have it, another beautiful graph sketched out. Good work, team. So hopefully this 5-point graphing method is feeling at least a little more familiar now, where you can sort of understand what we're doing and why a little bit. The homework is really a reflection of doing this sketching and getting some of these important values like period, max, min, equilibrium axis, amplitude, domain range, etc. All that good stuff. So tackle some of that homework. Lesson 4 is the big one. This is the one that'll be the most challenging, so make sure you're well rested before you tackle number 4. It will be complicated, there will be lots of parts to the lesson. Not trying to frighten you, mostly just so that you know what you're getting into when you start that lesson. You can absolutely do it. I'm going to be super thorough with it, so I have total faith in you. We'll see you in lesson number 4.